Draw the shear and moment diagrams for the beam. Indicate values at the supports and at the points where a change in load occurs. Alright, to solve this problem, first of all, we need to determine our external reaction forces on this beam. So we know because there, by inspection, there is no external horizontal reaction force on this beam. Therefore, our x is going to be 0. Our EY we need to find. And because this beam is embedded into the wall, there is also a moment involved in here. Okay, so to find our AY, we simply have to sum the forces that are acting vertically on this beam. So in this case, it's 8 and 3. Both are downwards, therefore negative. And solving for this, our AY is going to be 11 kilonewton. I did it in my head because it's super simple. And you can go back to other videos to find out how to solve for it if you don't know. And now our moment, for moment, we simply have to take moment about the point A. We're going to have 8 kilonewton, and it's 2 meters away, and then we have clockwise 3 kilonewton, and it's 4 meters away from A, all equals to 0. But before we do that, we have to remember that we have moment A, which is unknown, and it's counterclockwise, all equals to 0. On for moment A, we get our solution as 28 kilonewton. Now we can start solving for our shear and moment diagrams. So first we're going to start with our shear diagram. So we're going to have at beginning, we're going to start at 11 kilonewton. And then we have 8 kilonewton downwards at 2 meters. So we're going to go down 8. So 8. So 11 take away 8 is 3. So we're going to have 3 here. And then we're going to continue at the level of 3 until 2 more meters. And then we're going to go down. And we're going to get to 0. Okay. So that's our shear diagram. Now can start with the moment diagram. So for moment diagram, we're going to start at negative 28 kilonewton times meter. And this is our 0 order line. We need to determine our area here for this whole area. So it's simply going to be 11 times 2, which is 22. And it's positive, so this means our moment curve is going to go up, or the moment line in this case, or slope, you can say. So 22 take with 28 is 6. So we're going to have negative 6. So it's going to be in triangular shape, or you can say a simple slope, all the way till 6. And once we have 6, then we simply have to determine our area under this line here. And this is simply 3 times 2, which is 6. So this ultimately brings our moment diagram from negative 28 to 0. And that's our solution for this problem. Problem 14. Draw the shear and moment diagram for the beam. Indicate values at the supports and at the points where a change in load occurs. Just like before we begin with our shear and moment diagrams, we have to determine our external reaction forces. So at A, because it's a roller, we're going to have one vertical reaction force, and B, it's a pin, we're going to have A and horizontal, horizontal and vertical reaction. But we know that our horizontal reaction will be 0. And now we can solve for our A and BY. So to begin, we can take a moment about the point B to determine our value for vertical reaction at A. So simply going to be, so we have clockwise 6 kilonewton times meter given, and then we have counterclockwise 8 kilonewton, and it's 2 meters away. Then we have our unknown AY clockwise, and it's 4 meters away. Then we have our counterclockwise 6 kilonewton, and it's 8 meters away, all equals to 0. For AY, we get our solution as 14.5 kilonewton. Now we can sum the forces in y direction in order to find our solution for counter direction at B. So we're going to have positive By, positive 14.5 kilonewton, negative 8 plus 6, so that's 14, all equals to 0. Solving for By, we get our solution as 0.5 kilonewton. Okay, and with that, we can begin our solution, which is to draw our shear and moment diagrams. For our shear diagram, we're going to begin with negative 6 kilonewton. And then we're going to proceed till 4 or 4 meters, you can say. And then we're going to go up 14.5, which will get us to 8.5. And then we're going to move to the right for 2 meters. And then we encounter external reaction force of 8 kilonewton. So we're going to go down 8 kilonewton. And this means we are at 0.5 kilonewton now. And then we're going to proceed to the right again all the way till point B. At point B, we're going to go down 0.5. We get to 0. And getting our solution to 0 also means that we did our calculations correctly and we drew our shear diagram correctly as well. Okay, now we can proceed to moment diagram. So for moment diagram, we don't have moment at the beginning. So this means our moment diagram will start from 0. And then we need to determine this area, which is in negative. So it's 6 times 4, which is negative 24. And this is 0 order. So we're going to have first order of moment curve or line or slope, you can say. And this goes all the way till negative 24. I'm going to say this is negative 24. And just so you know, you already know, I believe, that all these graphs are not to scale. Okay, and after this, we have our next area, which is this area, which is simply 8.5 times 2. So, and this is in positive, so 8.5 times 2 is 17. So we're going to proceed 17 points up with our first degree slope. So 17 take with 24 is negative 24, pardon me, negative 7. So negative 7 is going to be somewhere here. Once we have our negative 7, now we can proceed with our last point, which is this. So 0.5 times 2 gives us 1. So this means right at point, close to point where the point B is, you're going to have negative 6. And this curve is also going to be first order. And then you have noticed here that we have 6 kilonewton clockwise. Clockwise, when we do our diagrams, it's positive. I know when we do our problems, I always take counterclockwise as positive. So yeah, so this is one thing you have to remember, or you can use clockwise as positive for both your equation and your diagrams. Anyways, or you can flip signs on the graphs as well, but that makes things complicated and I don't want to do that. Okay, anyways, so we're gonna have 6 kilonewton clockwise, so we go up 6 and we come to 0. So this means we drew our we drew our graph correctly. And with that,